Hi, this is Leetcode question. Divide nodes into the maximum number of groups. This is the last question of weekly contest 322. You are given a graph and you need to divide the nodes into multiple groups such that each node in the graph belongs to exactly one group. And for every pair of nodes in the graph that are connected by an edge AI BI, if AI belongs to the group with index X and BI belongs to the group with index Y, then the absolute value of Y minus X should be equal to 1. For example, node 1 and node 2 connected by this edge. Node 1 is part of group 2. Node 2 is part of group 3. 3 minus 2 equal 1. So this condition happens. We need to return the maximum number of groups into which you can divide the nodes. Return -1 if it's impossible to group the nodes with given conditions. So how can we solve this problem? Here is our graph, and remember that the graph can be disconnected as mentioned in the question. The given graph may be disconnected. First of all, we need to find all the sets in the graph. The set is defined as all the nodes that are connected together. So this is set 1, and all the nodes here are another set 2. Then this group is set 3. Then we need to find an answer for every set. So the answer or the solution is the maximum number of groups. We can split the nodes in this set. So for set 1, imagine the answer is A. For set 2, the answer is B. For set 3, the answer is 3. The final answer will be A plus B plus C. And if any of the sets return a value equal to -1, this means that our final answer will be -1, no matter what is the value or the answer of other sets. So first of all, how can we find these sets? To do that, we will use DFS algorithm by iterating over all the nodes in the graph and doing DFS to collect the connected nodes. So starting from node 1, and we have a Boolean array of length n plus 1. N is the number of nodes in the graph, and plus 1 because the node numbers are 1 indexed. So this Boolean array initialized to false, and starting from node 1, we need to check if it's already visited. It's not, because its value initially 1. So then we need to do DFS, and recursively every node we visit, we push it to set vector, and by this we will collect all the nodes that are connected to node 1, and by visiting these nodes, every corresponding element in the visited array will be equal to true. So after we collecting this set by doing DFS at 1, now at node 2 we need to check if we need to do DFS, but node 2 is already visited because its value will be true after the DFS for the first node. So no need to do DFS on node 2. Same for 3, for 4, for 5, for 6. For 7, the value will be false, so we will call DFS for node 7. And by calling DFS for node 7, we recursively collected all the nodes that can be reached from node 7, and we will push all of these nodes into another set. And by the end of this DFS, all these nodes are visited. So when we reach node 8, again, no need to do another DFS because it's visited, and we have all the nodes already for this set. The same for 9, for 10, for 11. They are visited because we call DFS for node 7. Also 12. Now node 13 is not visited, so we do DFS, and we will collect all the nodes in this set. So this is the first stage, is to know what are the sets in our graph. After that, we need to find a solution for every set, and to do that we will use PFS algorithm for every set. So first of all, we will find a solution for this set, and we will iterate for all the nodes. Like for every node, we will call the PFS function to find the solution if we start from this node, and at the end we will take the maximum value of all answers. And to do that, or the reason for why we are doing PFS is because here y minus x equal, or the absolute value of y minus x equal 1. So we need to traverse from a node level by level, and by visiting every next level, we will increase the group number. And remember, we cannot put two nodes connected together into the same group, because then they are part of the same group, and y minus x equal 0. So we need to do PFS. We will start from group or set 1, and as we said, we need to do PFS for every node. So if we start from node 1, we have Q, and we push this node into the queue, so the queue will have value 1, and then we pull all the nodes that are in the queue, or from the last level count. So the level count, when we push this node, initially it's 1, so we keep looping over all this number of nodes. So we take 1 from the queue, this will be 0, and 1 we will assign it the first group, which is group number 1. Then we need to push all of its neighbor into the queue. So we have neighbor 4, 2, 5. So the queue now has 3 nodes. The next level is 3 nodes: 4, 2, 5, and all these nodes, now we will pull them from the queue. We assign it assign them the second or the last group number, which is 1 plus 1, 2. So these three nodes will have group number 2. So node number 1 has group now 1. The neighbors will have group number 2, 2, 2. And we will do the same for every node. So for example, node number 2, it has two unvisited neighbors, 3 and 6. These two neighbors will have group number 3, and this will be the answer for this solution is 3 groups. Then we need to do another PFS starting from another root node. So let's start from node number 5. Starting from node number 5, the first node takes group number 1, then its neighbor group number 2, its neighbors the unvisited one take group 3. Then for this node we have two neighbors, so will be assigned group number 4, and so the answer of this is 4. And we continue at the end. We will take the maximum among all of these answer, and that will be the answer for set 1. Then we need to do the same for set 2. We iterate over all the nodes and finding the solution. Then set 3, then we will add all the results together. And remember that when we are checking some node, after we assign it group, imagine the last group number is 2. So for node 4 we will assign it node number 3. Now we need to check all its neighbors that assigned value to see if the conditions meet. So here 4 minus 3 equal 1, which is good. 3 minus 2 equal 1, which is good. And we are doing this to check for minus 1 condition if there is a loop. So for example, if this is our graph like this, so initially if we start from node number 1, node number 1 will take group number 1, then its neighbors 2 will take a group number 2, and when we check for node 2, for example, we need to check all of its visited neighbor. So this is visited neighbor has value 1, this is its visited neighbor has value 2, but 2 minus 2 equals 0, so the condition does not meet, and in this case we need to return minus 1 as final answer. So let's look into the implementation. First of all, we are given vector of edges, so we need to build our adjacent list or our graph. So the graph is vector of list or vector of vector. After we build our graph, we need to find the sets using DFS algorithm. So here we have vector of integer of the set that we need to fill it using DFS algorithm. Here if visited node we return the other than that we need to push this node into the set, and then we need to recursively visit all the neighbors. So after we collected the set, we need to find the solution for this set using PFS algorithm, and here check set function. We have Q, and we have the group number. Initially it's 0. So the first node is in the queue, we pop it, and group number will be 1. So we assign this group number to the root node. And as we said, we loop over all the node in the set to do PFS algorithm. And if any of them has value -1, we return it directly. Otherwise we will do the max of answer and the group number. And as we said, for every node we need to check if the group table of or the visited node, the neighbor visited node has group value that's the difference is not equal 1, we need to return our answer, which is -1. And after we find the result for this set, if it's -1 we return directly, otherwise we add the answer to our final answer.